Uh, I'm going to speak a few minutes. Our book on global warming has been published this month by Elsevier, a major international publisher of scientific and technical books and scientific journals. Global warming is an issue that has been largely ignored for at least 30 years. However, and please excuse the pun, it's becoming a hot issue. It's a very important topic and could be a major campaign issue. The Republicans are concerned that addressing global warming would damage the US economy. On the other side, the Democrats, Vice President Biden has stated that he's going to spend $2 trillion during his first term of office fighting global warming. In addition, a House Select Committee has released a 500-page report recently entitled Solving the Climate Crisis, and the purpose of the report is to reach net zero by 2050, only 30 years from now. Craig and I don't support either approach, do nothing or an expensive government crash effort that could lead to a lot of waste and end in failure. We are in favor of getting the incentives right to maximize private sector efforts and investment and to smoothly transition from our energy use from fossil fuels to renewables, trying to minimize the impact on the global economy. Now I'd like to turn the podium over to Craig, who will start our presentation.
Thank you, Bill, and welcome all of our guests this morning. We appreciate you taking the time to listen to us. You might be wondering why two 80-year-old retired engineers are spending their golden years researching and writing a book on global warming. Well, we are writing it not so much because we're concerned about ourselves, but because of our children and our grandchildren. There's been a lot written about global warming and the negative consequences on our environment and climate. Our book has, we believe, a complete treatment of the science and what should be done, what can be done, and what should be done about this problem. One of the difficulties we see is that a lot of this information is not readily available to the general public, or it's rather difficult to understand by concerned members of the public and policymakers. The first thing that we noticed as we began our research was that the Earth's temperature is rising. And I want to just explain about that, what I mean by that, because it's commonly reported as the Earth's average temperature. So the average temperature is a single temperature for the entire Earth, and it's based on thousands of measurements made all around the globe by different organizations and then brought together in a mathematical process to reflect what is the, quote, average temperature. That temperature has a baseline of 50 years prior to and following the Industrial Revolution, before we started widespread use of fossil fuels. So in the ensuing time up to the present, the average temperature has increased 1.1 degrees centigrade, or about 2 degrees Fahrenheit. In parallel with the temperature of the Earth, the average temperature of the oceans have increased 0.8 degrees centigrade, about 1.4 degrees Fahrenheit. And also during that time period, the sea level has risen about 250 millimeters or 10 inches, in part due to thermal expansion and in part due to melting of ice. Well, I just want to conclude by mentioning, as an example, glaciers are melting all over the world. The Columbia Glacier in Alaska, which is pictured in this slide, has retreated 4 miles in the last 6 years. What causes, what are these greenhouse gases, and where are they coming from? Carbon dioxide amounts to 3/4 of the total. About 2/3 of it is coming from combustion of fossil fuels and industrial processes, and about 11% from agricultural related uses. In addition, there are some other greenhouse gases: methane, nitrous oxides, and the fluorinated gases, primarily from industry, which make up the balance. But of the total, then fossil fuel use accounts for 3/4 of the greenhouse gases, and agriculture and forestry, land use changes about 25%. Now, who's responsible for emitting these greenhouse gases? China is the major emitter, having surpassed the US a few years back. Today, China emits 30% of all the emissions, the US 15%, and another 5 countries account for the balance other than the rest of the world. So if you look at the per capita emissions, it's a slightly different story. The US has the highest per capita emissions of any country, about twice China, and about 3 times the amount of the rest of the world. Where do these greenhouse gases go? Well, the oceans absorb 30% of the carbon dioxide, and another 30% is absorbed on the earth by plants and the earth, leaving 40% to go into the atmosphere. These gases in the atmosphere are like the glass in a greenhouse. So adding glass to the greenhouse increases its ability to stay warm inside. Part of the heat goes into the atmosphere, but the majority, 90%, goes into the oceans. And that would be beneficial, because without the huge heat sink of the oceans, the Earth would be even warmer. However, the carbon dioxide going into the ocean produces ocean acidification, which is another problem. In our book, we talk about 12 different examples of the effects of global warming that are being experienced somewhere in the world today. In this slide, we mentioned a couple of the most important ones: more frequent and intense storms, as Bob Curry mentioned in his introduction, the destruction of coral reefs by ocean acidification. This is a picture of a segment of the Great Barrier Reef in Australia with all the dead coral. Likewise, the rising temperatures are increasing desertification, causing climate zones to change. Animals and plants have to migrate to typically higher elevations, and if they can't adopt, then they will become extinct. Finally, in the lower left-hand corner of this slide is a picture of the street I live on in Newport Beach. My house is 10 feet above mean sea level. We've had flooding of this sort a number of times in the last few years. So I have a personal concern about sea level rise. What is net zero? I want to say a few words about that, because that is the title of our book. And basically, net zero is a term that's been coined by the Intergovernmental Commission on Climate Change to describe what needs to be done if we are to stop or avoid the worst effects of global warming. What it means is we have to reduce emissions to the point of zero. Last year, 2019, the world emitted 55 billion metric tons of greenhouse gases into the atmosphere. Very difficult to even imagine the magnitude of that number. In reality, we will not be able to reduce that to zero. There are some emissions that will be difficult or impossible to eliminate. An example might be liquid fuels used in airplane travel. So to reach net zero, for the man-made emissions that we cannot eliminate, we have to find ways to capture or absorb them on the earth, either through land or plants, sequestration of CO2, or by means yet undeveloped to basically suck CO2 out of the atmosphere and store it safely underground. Bill and I have coined an analogy to help explain this, which we refer to as a sticky accelerator problem. Basically, what that says is that we can speed up global warming, but we can't slow it down and we can't stop it. In other words, there are no brakes and the accelerator doesn't retract. Well, why is that? Well, that's because if greenhouse gas emissions cease, if we were able to stop it tomorrow, the global warming would persist until these gases are slowly and eventually removed from the atmosphere over a period of hundreds of years. There's another problem associated with that, and that is what we call latency. In other words, some effects of global warming will not be visible for perhaps decades. So things are happening, but the results are not yet apparent. So it's very important that we start now to do something about this problem. If you want to put it a different way, we could say we're driving without brakes and we don't slow down when we take our foot off the accelerator. At this point, Bill will take over.
On the left side of this slide, you see the buildup of fossil fuel use since roughly the start of the Industrial Revolution in the U.S. The Industrial Revolution started in the UK about 1750 with the invention of the steam engine that was used in mining, railroads, and industry, and led to the rapid increase in the use of coal, as you can see in the chart. With the invention of the internal combustion engine, the use of oil took off, mainly in the form of gasoline and diesel fuel. And that was later followed by natural gas used for heating and for the production of electricity in power plants. And then a not insignificant amount of carbon dioxide is related to cement production. And cement is the most widely used construction material in the world today. And this has led to a very rapid buildup over the last 150 or more years in the use of fossil fuels. We can see that this essentially exponential growth in fossil fuels has led to the buildup of CO2 in the atmosphere, as you can see on the right side of this slide. The buildup of CO2 obviously follows the use of fossil fuels. We have to point out that without this use of fossil fuels, our modern economy and our lifestyle today would not have been possible. We needed the energy from these fossil fuels. However, we have reached a point where continuing to use these fossil fuels as our primary source of energy is damaging the environment as well as threatening mankind. We believe that now we are fortunate that technology has allowed us to displace fossil fuels with renewables, mainly solar and wind, and it is possible to produce abundant and affordable energy through using renewables. What drives energy use? There are really just two factors. In the small chart in the upper left, you can see it's population growth. More people use more energy, and you can see a very close two trends. One is population growth and the other is energy use, closely paralleling each other. The other major factor is rising standards of living. As you can see in the red arrow, as people's standard of living improves, they use more energy for transportation, lighting, heating, air conditioning, and for the purchase and distribution of goods and services that are made possible as people's incomes rise. One question that people ask is, do we need energy austerity to fight global warming? Do we need to use less energy and go on a diet? We don't believe this is necessary. We believe that it's now possible to produce both abundant and affordable energy using renewables. Next slide. An often repeated argument is that global warming is a natural phenomenon and it's not man-made and there's nothing we can do about it. this is just not true. Thanks to years of scientific research, it's possible to reconstruct the Earth's temperature and the Earth's CO2 concentration back hundreds of thousands of years using ice cores and other means. The figure here shows the Earth's temperature and CO2 concentrations for the last 350,000 years. The Earth's climate is governed by the Milankovitch cycles. These are changes in the distance and the orientation of the Earth relative to the sun, our only source of energy. You can see with the red arrows here on the chart that a full Milankovitch cycle takes 100,000 years. Today, we are seeing changes that occur in decades, much too fast to be caused by the Milankovitch cycles. In addition, over the last hundreds of thousands of years, the CO2 concentration in the atmosphere has not exceeded 280 parts per million. But we can see on the upper right a spiking of the CO2 concentration. And at the beginning of this year, 2020, it reached 411 parts per million. And that was about 50% higher than the peak of the last several 100,000 years. Looking at the data more recently, you can see a very close correlation between CO2 increases, the darker line, and the Earth's temperature. The Earth's temperature has increased 1.1 degrees centigrade, about 2 degrees Fahrenheit, over this period, and is increasing at the rate of about 0.2 of a degree centigrade per decade, and that rate is increasing. At this rate, it's estimated that global warming will exceed 3 degrees centigrade, about 5.4 degrees Fahrenheit, by the end of this century. In 2019, last year, we set a record for greenhouse gas emissions of 55 billion metric tons. That's 55 gigatons. In addition, it's noted that over half of all the man-made greenhouse gas emissions were put into the atmosphere in the last 30 years. We're increasing the amount of greenhouse gases quite rapidly. We're digging a very big hole for ourselves. Where are we headed? If present trends continue, global greenhouse gas emissions will continue to increase and could reach 80 gigatons by 2050, 30 years from now. That's an unimaginable number. Gigaton, how big is a gigaton? Craig and I have found that 1 gigaton is the weight of 150 million male African elephants, just as an example. And that's a lot. And today, there's only 400,000 African elephants of all sizes in the world today. So there's a huge gap between where we're headed and where we need to be. The green line on the chart is what it would take to limit global warming to under 1.5 degrees centigrade. We'd have to get to net zero by 2050, only 30 years from now. This raises the question, what is our global warming objective? The Intergovernmental Panel on Climate Change, the IPCC, has established a goal of limiting global warming to less than 2 degrees centigrade. In addition, the Alliance of Small Island Nations in the Pacific asked for the lower limit, 1.5 degrees centigrade, because they're very concerned about the effect of sea level rise on these low-lying islands in the Pacific. In addition, the Paris Agreement, the major international agreement in effect, which was signed in 2015, has stated that their goal is to keep global warming under 2 degrees centigrade with an attempt to pursue a goal of 1.5 degrees centigrade. In our opinion, both of these goals will be exceeded. There's no way we can stay under 2 degrees centigrade. Next, please. Why is it so difficult to reach net zero? We have to think about what's required. A couple of things come to mind. First of all, we've not had any wake-up call. Uh, there's nothing like a 9/11 or a Pearl Harbor to arouse public concern. The general public hears about global warming, but they don't experience anything related to global warming in their day-to-day lives. It's something that's happening somewhere else or far in the future. And even if they're concerned, they don't know what to do about it, which is what we're trying to discuss in our book. Also, we believe that our politicians won't take action if the public isn't behind them. Today, for example, there'd be widespread opposition to any increase in gasoline prices or electricity prices related to doing something about global warming. The politicians won't take action if the voting public is not behind them. The other is just the magnitude of what we have to do. We have to eliminate fossil fuel use and also use renewables and expand the carbon sinks that absorb CO2 from the atmosphere. In addition, the fossil fuel industry is a huge business. A lot of companies and millions of people make their living on fossil fuels. And so there's an understandable reluctance to make a change. And perhaps one of the most difficult tasks is the need for unprecedented global cooperation. All of the major industrial economies have to work together to pursue net zero. If the US, for instance, did everything it could and China or India or others did not follow suit, we'd be putting our economy at a great disadvantage and not doing enough to solve the problem. It will require an unprecedented amount of global cooperation in spite of many differences between the countries involved. You have to ask, what if we don't do enough, or what if we don't do anything? We certainly recognize that failure is an option. As seen on the right side of this slide, CO2 and other greenhouse gases would continue to build up in the atmosphere, and there'd be a corresponding increase in temperature that's estimated to be about 3 degrees Fahrenheit by the end of this century. In addition, as you see on the left, the sea level will continue to rise. To date, much of the sea level increase has been due to thermal expansion, due to the modest heating of the ocean, and from ice melting, from ice caps and glaciers. And this melting is accelerating. In the ice cap of Greenland, for instance, and the ice shelves in Antarctica are melting faster. And it's now estimated that the sea level rise could exceed a meter, which would be 3.3 feet by the end of this century. Another thing, if we don't do something about global warming, is we have to worry about what is referred to as tipping points. A tipping point would be an abrupt or irreversible change in global warming that would be triggered if we exceeded some limit. This would be basically the famous straw that broke the camel's back. From what we know today, it's not possible to predict when we would reach one of these tipping points and what the effect would be, so they're not included in our forecast, and then the forecast we've reviewed. However, there's at least 9 major tipping points that are of concern, such as the failure of the monsoon in India, perhaps the slowing down of a major ocean current like the Gulf Stream, or melting permafrost in the Arctic, releasing rapidly increasing large amounts of methane. We don't know when one or more of these tipping points could be reached, but we have to be concerned about that. So where are we? We can stop global warming. We believe that's technically possible, but will we? As we were completing the editing of our book in earlier this year, the world was hit by the coronavirus, and this has had a very disastrous effect on health and the global economy. This pandemic, in a way, could serve as a wake-up call for global warming. With the pandemic, we will eventually get a vaccine and the economy will recover given time. We have to point out, though, that with global warming, there is no vaccine and no solution other than reaching net zero. I'll turn the presentation back to Craig.
I want to give a brief description of what Bill and I think needs to be done. First thing is to improve energy efficiency and conservation. Following the 1973 oil embargo, oil prices literally tripled overnight. And many of you in this room will remember the gas lines and the time we had to spend searching for fuel and a concern about rising prices. One of the effects of that was to spur or stimulate an increase in innovation and invention, and things such as new refrigerators that required 1/4 the amount of energy as previously, or changing incandescent lamps to compact fluorescence, and then ultimately to LEDs that use a fraction of the energy and produce a higher quality light. Those things were part of a process that over the last 50 years or so has reduced energy use per gross domestic product by an average of 2% per year, continuous over that period of time. We believe that it's possible to continue that and increase it to 3% per year. Another part of that is vehicles with improved mileage standards, then moving to hybrids. We also need to produce all electricity with renewable energy. Wind, solar, our remaining nuclear plants, hydro, and even geothermal and tidal where that's feasible. We need to substitute electricity for power and heat uses and applications in industry using electric ovens, microwave heating processes, and so on, rather than burning natural gas. We need to hasten the transition to electric vehicles. Many manufacturers today are retooling their production processes to make electric vehicles, not just passenger cars, but trucks and buses as well. We need to improve methods for making hydrogen fuels more economical and to develop other synthetic fuels to replace liquid petroleum products. We have to make changes in agriculture to reduce energy intensity and improve sustainability of agriculture. And then finally, we need to plant billions of trees, literally 1 billion trees a year for the next 30 years. And believe it or not, that is feasible to do that. It's too late to limit global warming to less than 2 degrees C. As Bill mentioned earlier, we don't believe it's possible by 2050 to limit global warming to 2 degrees C, and certainly not to 1.5 degrees C, when you consider that we're already at 1.1 degrees centigrade. So what can we do? We think that the technology is available and it's proven technology that's cost effective that can be deployed today. The problem in our mind is not the technology, but rather it's the will to move forward and to take action. Our plan involves the measures that I just described in the previous slide. So for each one of those, we've determined the time it would take to implement them and what reduction in greenhouse gas emissions could be achieved with each of those various measures. We've summed up the results of that in the blue curve in this graph. What that yields is that by 2050, we could have a 40% reduction in greenhouse gas emissions compared to the base plan of business as usual. That's not enough to get us to net zero, obviously. But the curve is moving downward at that point. And that's a good sign. And it also buys time for additional developments and improvements. By 2050, with the implementation of this plan, we would be back close to the year 2000, 20 years earlier, the emissions level, that is. It would give us time to find ways to make artificial fuels from hydrogen and carbon dioxide, and ways to remove carbon dioxide efficiently and safely and store it underground. Finally, as engineers, we know that once we get people working on complicated problems like this, new solutions that have not previously been thought of will be found. The key thing is that we need to start now. I think that's a message we'd like to leave all of you with, is that we need to get moving on this problem. Bill mentioned earlier, it's been decades. This problem was first called to the attention of Congress and several presidents 3 decades ago. Nothing happened other than lip service. Even worse, we withdrew from the Paris Accord, the only country in the world not participating. We need to avoid further delays. There are 3 big things we believe need to be done. The first is to get the public on board. We need to get the public convinced that it is a real problem and not a hoax or not something that is insolvable. Perhaps something like the equivalent of the 1964 Surgeon General's report, which linked lung cancer to smoking and finally caused smoking to be taken seriously as a problem. The second thing is that we need to implement a carbon emissions fee applied at the wellhead and the mine. Currently, globally, the world spends about $5 trillion a year in subsidies for fossil fuels. That is for depletion allowances, tax credits, and most importantly, there is no charge for discharging pollutants into the atmosphere. The carbon fee revenues could be used to address those problems and also to fund the construction of new renewable energy power plants that will be cheaper to build and will not have expensive annual fuel bills. And you have to recall or remember that over the next 30 years, many existing power plants are going to retire anyway, and will have to be replaced in some form or another anyway. Finally, the third thing is we need to launch cooperative agreements, international agreements to address this problem. We can't do it by one country or even a half a dozen countries. It's going to take a global effort. We think a bright future could be our reward. We are not believing in a message of doom and gloom, as it were. We're optimistic that we can do better than that. Again, as I mentioned earlier, stopping global warming, not so much a technical problem as a problem of political will. And it doesn't need to imply austerity. We think there can be abundant and affordable energy from renewables. Actually, today, solar and wind generation is cheaper than coal and nuclear power plants, and is on par with natural gas. The trends are moving in the right direction. They're just not moving fast enough. The other benefit of this would be to remove and eliminate most air pollution. As I mentioned earlier, the technology needed is available today to get us started in the right direction. The US and many other countries could become energy independent. With the right incentives, much of the investment could come from the private sector and not require government or debt financing. So to sum up, we can solve this problem. We need to rally the political support, and we need to get started without further delay. Today's vision of our future world is not the legacy we want to leave our grandchildren. We respectfully ask for your help in creating a bright future. Thank you very much.